Hello, I'm Neil Charnas. Welcome to our Create session. I'm going to start with a brief overview of Create. What are we? We're a multidisciplinary collaborative center that started back in 1999 and has been funded continuously by NIH-NIA for the past 20 years. Today, the principals are at Weill Cornell Medicine, University of Miami, Florida State University, and University of Illinois at Urbana-Champaign. What are the goals of Create? We want to understand how person characteristics influence person-technology interactions across a broad range of technologies, existing and emerging, and across a broad and diverse population of older adults. We also are expecting that we can develop and evaluate design solutions to promote successful technology adoption among older people, ensure that the potential benefits of technology are realized in these populations, and understand how interactions with technology impact quality of life and well-being. We also, over the years, have been trying to develop principles and protocols to aid in design, in implementation, and in evaluation of emerging technologies. We're trying to promote new areas of research and training of new investigators. We want to disseminate our findings and products to a broad audience, like this one, and foster collaborations with others working in the aging and technology domain. So my topic today is to look at technology, past, present, and future. And as I pointed out quite some years back, we're in the midst of two striking trends: widespread population aging and a rapid diffusion of technology. Population aging is a function of increasing life expectancy and decreasing size of birth cohorts, that is, declines in fertility. And you can see the black line is the world as a whole. Things have been moving in a positive direction for a very long time and are expected to continue. If you look even at Africa, back in 1950, life expectancy of birth was about 37 years. In other words, what the US had 50 years before in 1900. But everybody's heading in the same direction. Higher percentages of their population over 60 or over 65. The other trend that people probably have noticed informally is the increasing rate of diffusion of technology. And we can see it with a variety of devices invented at different times, like the fax machine in 1843 by Alexander Bain. It was up to about 50% adoption in our estimation in the US by about 1990. In other words, it took about 150 years to hit that point. But then look at what happened with things like the telephone, 44 years, the microprocessor, 30 years, the internet, only 18 years before it was in half the homes in the United States. If you put those two trends together, one of the discomforting findings is the age lag in technology adoption. And you can see it here with European Union data on the left and US data on the right. If we look at the oldest cohort plotted, the 65 to 74-year-old group here in the EU, you'll notice that although there's been an increasing trend of adoption of weekly or higher internet access by 65 to 74-year-olds, from about 20% back in 2009 to about almost 50% in 2018. And you see similar data extending back a little further to the year 2000. What you can see is this consistent age lag in technology adoption by different age groups. And we want to understand why and what we can do about it, particularly with better design principles. Okay, let's talk about the future a little bit. I think there are a number of factors that will try to, that we think can either positively increase or perhaps delay the speed up in technology diffusion. One of them is global warming with stronger storms. We see a lot of them this year in the United States. We see a huge increase in number of fires, which also affects our power grid. So global warming, I think, is a threat to our centralized power supply model. And countering that, perhaps, are declines in power consumption. We've seen power consumption dropping in the average US household in the past few years. And so I think lower power transmission of information, more effective information transmission, probably that's going to continue, since that's an increasingly important part of the infrastructure for new technology products. I think acceleration is likely to be maintained. People factors, I think older cohort technology lags are going to persist. Why? Because in part the cost of new learning for older adults is much higher than it is for younger. It takes about twice as long for them to learn something new and unrelated to their prior experience compared with, say, a 20-year-old. However, experience can possibly offset some of those costs of new technology learning, making it less of a barrier for technology adoption. But on the whole, I expect technology lags to continue. Another interesting trend is miniaturization. You can see the trend clearly for telephones, starting from the Motorola, the first cell phone. If you look at the size of the device, it's been shrinking steadily, although then screen size has started to increase. Increased screen size, great thing for older users, particularly because visual acuity tends to decline. Even best corrected acuity declines as people age. And maximum screen size is going to be determined in part by ergonomics. The hand only comfortably holds devices of a certain size, although, again, we're starting to see some breaks in that with foldable screens. The other big change I see is Internet of Things devices diffusion, in particular because of AI-driven natural language interfaces. You can think of Alexa, Google Assistant, those types of devices. Adaptive AI that learns user behavior to make predictions. You see this with auto-completion on your smartphone as an example. Those are going to continue to help to drive the Internet of Things devices into the homes of older adults. The other interesting shift, though, is US households. They're shifting from wired to wireless connectivity. Over the past few years, we've seen a decline in broadband use in older, not use, but broadband enrollments in the homes of the US, of people in the US. We've seen an increase in cellular connectivity as the only connectivity source in American homes. And then, of course, now with 5G, we may see wireless starting to displace other forms of wired broadband. Robots, that's another area where I think there is a potential for impact on successful aging, particularly if you think about social robots, assistive robots, telepresence robots as examples. The challenge, though, is that even as recently as 2017, almost 2/3 of Americans were totally unaware of social robots, and they've been a failure so far in the marketplace, despite a number of popular startups. Finally, I think an important area is going to be transportation technology. We certainly see advanced driver assistance systems embedded in most new vehicles now, which help with things like forward collision warning, blind spot detection, countering lane drift, which is a source of crashes, particularly for older adults. On-demand services. We've always had taxis. That's an on-demand service. It didn't require high technology, just a telephone call. But Uber, Lyft, Didi can bridge gaps in public transportation, although not so much in rural areas. Autonomous vehicles, they've been coming for the last 10 years. They're still probably at least 10 years out, fully autonomous vehicles. And even if they are finally deployed, we'll still have to solve the last 10-meter issue. How do you get a mobility impaired older adult from their homes into the vehicle, and then from the vehicles to their final destination? Social structures, a lot of changes here, mostly in terms of lower levels of resource because of more single parent families, smaller family sizes, A good trend is the period of widowhood may be shortening because the life expectancy gap between men and women has been showing signs of closing. And the other counter trend is the growth in never married and childless seniors. And so smaller family units mean fewer resources available to aging family members. So caregiving support is going to be an area where ICT plays a really important role. And that'll intensify, particularly if after the current novel coronavirus epidemic starts to wane and decline. Family mobility may continue to increase, which means probabilities of younger family members living in different cities than older family members. So access to remote caregiving technology is going to be increasingly important. All right, so in summary, I think there's going to be a persistence of the need for good design and good design principles, what CREATE has been working at for the past 20 years. I think the next 20 years are unlikely to produce drastic changes in human capabilities and human motivations that impact technology adoption and use. The environment side, I think, a lot less certain, particularly given climate change and also the rate of technology product development. I think a safe prediction is that connectivity to the internet is going to be incorporated into most ICT devices. In my home, we have light bulbs that literally have internet connectivity. And I think good design for aging populations is still going to be necessary. Thank you so much.
Hello, I'm Sarah Sasha, and I'm very happy to be part of this symposium. I'm from Weill Cornell Medicine. Today, I'm going to talk to you about technology, healthcare, and aging adults. I'd like to acknowledge the National Institutes on Aging, who has supported our research in this area over the years. I'll begin by talking about some healthcare trends. The increasing number of older adults in what's called the oldest old cohort, these are people 85 and older, is causing concern as they typically have more chronic conditions and require more care and assistance. For example, if we look at some data from the United States on the projection of Alzheimer's disease prevalence, we can see that unless we find a cure, the number of people who have Alzheimer's disease is going to increase rather dramatically in the upcoming decades, especially in that group I targeted, the oldest old. Being over the age of 65 is also associated with an increased likelihood of developing one or more of other types of chronic conditions, such as arthritis, diabetes, hypertension, or heart disease. At the same time, there are other trends in healthcare. One is that we're moving towards a more partnership model of care, partnerships between patients and providers, where consumers are expected to play a more active role in the management of their health. And there's a trend from inpatient to outpatient care in home settings where people are caring for chronic conditions in their home. And family caregivers are playing a huge role here. They represent a significant support for aging adults with a chronic illness or disability. Right now, in the United States, about 16 million people provide care to someone with dementia. Most of these caregivers are family members or friends. And as we might expect, technology is playing an increasing role within the healthcare domain. With the COVID pandemic, some special challenges have arisen, especially for aging adults and their family. The stay-at-home and pause requirements have dramatically diminished older adults' opportunities for cognitive, social, and physical engagement, limited their access to routine medical care, social support networks, and other kinds of support such as group meals, planned activities, religious services. Families have had limitations in their ability to interact with their aging relatives. Of course, there are increased problems with social isolation and loneliness, which lead to deleterious health outcomes. And the use of technology in healthcare has become even more pronounced. For example, during the height of the pandemic in New York City, At my hospital, Weill Cornell Medicine, we were doing about 2,000 daily virtual visits. So what does this mean for older adults? Well, many older adults really have lack of access to resources and to needed care. This is particularly true for those who live in rural locations of lower socioeconomic strata or minorities. Still today, we have age-related digital inequalities in terms of not only technology access, but support, uptake, and proficiency. If we just look at the graph presented, this is some data, recent data from the Pew Research Group showing percentage of people in certain age groups who own a smartphone. As we can see very clearly, those 65 and older, the percentage of people who own a smartphone are still much lower than other age groups. Many older adults have low health literacy, which becomes problematic when using healthcare technologies. And I think overall, there's been a lack of consideration of the needs, preferences, and abilities of older adults in the design of healthcare technologies. So in CREATE, over the years, we've been looking at the design and use of healthcare technologies by aging adults in a number of areas, including telemedicine, electronic health records, healthcare in the home, and acceptance and adoption of healthcare technologies. I'm just going to show you a few snippets of our research in this area. We did a study a while ago, this was when I was still in Miami, where we did a pilot study where we looked at the use of a telehealth system by older adults with hypertension. The system was very simple. There was a blood pressure measuring device, which you can see on the screen, a body weight scale, which is not displayed, and then a pod, which is also displayed, which was a wireless unit to transfer data to nurses who were part of the study in a healthcare organization. Our sample was small because it was a pilot study. We had 34 hypertensive older adults whose average age was 72. Most were Hispanic and most had limited education and computer experience. And we also had 2 nurse participants. Our main findings were very encouraging in terms of the opportunities of telehealth for older adults or telemedicine. The majority of our older adults found the device easy to use. They thought that having the device improved their knowledge about their health and made them more compliant in their medical plan. And also on the positive note, the nurses thought that the technology helped prevent hospital readmissions as it made them more knowledgeable about their patients. They would get alerts, for example, if the measurements were out of range. Another area that we've been looking at, and we've done a number of studies in this over the years, is older adults using the internet for getting information about health. And our main findings are displayed here, that certainly older adults are increasingly using the internet as a source of health information. However, they do experience some challenges. One is, how do I integrate information across the various websites that have information about a particular health topic? Also challenges navigating through websites which are complex, and many healthcare websites are complex. Identifying out of an array of websites about a topic, which ones are credible, and challenges comprehending what is often very highly technical medicalese information. We've also found, and this is important, in that cognitive abilities like working memory and processing speed, which tend to decline with age, prior technology experience, and health literacy are important predictors of performance of these kinds of tasks. And as we saw earlier, there still remains a digital divide for many older people, and health literacy, at least in the United States, tends to be low among many older adults. And finally, we've done some work with electronic health records. This was our student, Jessica Taha. We actually built a simulation of the EPIC patient portal, and we examined the usability of this with a diverse sample of adults. We had them perform tasks using the portal, like finding health information, scheduling appointments, interpreting test results, finding information about medication dosages. And our main findings were kind of mixed. We found that people had positive attitudes about the technology. They thought that using an electronic health record would help them access their health, accessing health information, and most said that they in fact would use an electronic health record if they had access to one. However, looking at the performance told a different story. Only a small percentage of our sample could interpret a blood pressure risk calculator graph or identify normal range values out of normal range values for test results, accurately determine the dosage for medication, or even navigate to a link for medication information. So the question, I think, an important question for Gerontechnology is, how do we foster and facilitate meaningful access to health care technology for aging populations, not only in terms of not only design of systems, also training and instructional support, technology implementation support. And this involves a number of things, obviously including older adults in the design process and considering their needs, abilities, characteristics, as well as their preferences in system design. And we have to think broadly about user groups here. It's not just the older person. It may also be providers or family members, and consideration of issues related to privacy and trust. And finally, besides design, I think we really have to have advocacy around issues related to the digital divide. Thank you very much.
Hi, my name is Wendy Rogers. I am the Kahn Professor of Applied Health Sciences at the University of Illinois, Urbana-Champaign. Today, I would like to spend some time talking about the idea of technology for supporting social engagement and the potential of technology. First, I'd like to make the distinction between isolation and loneliness. Social isolation is an objective state. So it's a situation where a person is simply lacking people with whom to interact. On the other hand, loneliness is a subjective negative feeling. It's a person's perception and their experience of deficient social relations. So a person can be socially isolated but not feel lonely, or on the other hand, a person can have a large social network but still experience some loneliness. We explored these ideas in the PRISM project, where we used the UCLA loneliness scale. We recruited individuals who we identified as being at risk for social isolation. And these were people who were over the age of 65, they lived alone in the community, they had minimal computer and internet experience, and they didn't work or volunteer or go to senior centers. So of the 300 people, what we found was, even though they were at risk for social isolation, their loneliness was normally distributed. So some people experienced loneliness in this situation, whereas others did not. However, it's important to note that loneliness was important for predicting depression. So in our modeling here, we found that both social support and social isolation predicted loneliness, and loneliness and social isolation directly predicted depression. We found the same thing similar pattern looking at predictors of health markers. So it's important to understand this construct of loneliness because it does have clear outcomes for health. That led us to our technology intervention. And in the PRISM study, these 300 participants, that was the baseline data that we were sharing, they were assigned either to the PRISM condition, which was our system that we had designed specifically for older adults, or they were assigned to the control condition, which was a notebook that provided similar information. It had a classroom, it had calendar, games, community resources, and so forth. And we tracked both groups of participants over the course of 12 months. Now, I only have a limited amount of time today, but I encourage you to look at our 2 papers that describe the trial characteristics in depth as well as our results. I just want to highlight 2 things here today. First is that over time, loneliness decreased more for the people in the PRISM condition, the people who had the technology intervention compared to the control. We also found an increase in social support for the people in the technology intervention condition. So it's important to think about what we mean by social engagement in this context. And you can think about it as the extent to which a person participates in the community, in their society, in their relationships. And it involves activities, maybe doing something together or interacting with other people, perhaps the exchange of ideas or information. And it's influenced by opportunity. So the social interactions, the social networks that people have, but also the social resources that are available within one's community or geographical area. And so we want to think about the potential of technology to support these social interactions. That's one of the goals of the CREATE Center. And we're focusing on a number of different potential technologies, and I'm just going to give a couple of examples. First is video support for social interaction. And in this project, we're partnering with a company called OneClick. And the title of our project is Enhancing Quality of Life for Older Adults with and Without Mild Cognitive Impairment through Social Engagement over Video Technology. And we're using this OneClick system. And one of the benefits of the system is it provides the social interaction, the voice, the face, facial expressions, body language, etc. But it's all done on the web. So the older adults don't need to download anything. All they need is a computer and an internet connection. And then we provide them with a link to an event and they just join the event. And these events provide the opportunity to participate in discussion groups, to connect with people who have shared interests, and to be able to learn new things, art, history, travel, and so on. So we think this technology has a lot of potential, and we're looking forward to evaluating the benefits over more extended interactions. Another topic of technology that we're focusing on is socially assistive robots. And these are the intersection of assistive robots, robots that are designed to provide assistance of some sort, and socially interactive robots that are primarily focusing on communication with the user, either through social or through just non-physical interactions. And so we're exploring the value of socially assistive robots, both to help people do things, but also to provide social support or social interaction opportunities. The third general category is digital home assistant technologies. We've been focusing primarily on the Amazon Echo products. They come in different forms. So there's the Amazon Echo Plus, the Amazon Dot, the Amazon Show, and there are new versions being released fairly often. And what we have found is that older adults are open to adopting these technologies, and they have a lot of potential to provide this voice interaction that enables support for everyday tasks, functional autonomy, physical activity, but also potentially supporting their social networks and engagement. So I think it's important overall for us to think about the fact that higher levels of social engagement for older adults have been shown to have a number of different benefits, which we reviewed in a recent book chapter. Reduced hypertension, decreased development of dementia, increased mental health and psychological well-being, and even reduced mortality rates in a number of studies. And so I encourage everybody to think about how can we use technology to increase levels of social engagement with the potential benefits for their health. We've been using social interaction technology for my lab, continuing to collaborate to do this work through the wonders of Zoom. And so I encourage you to go to our website to learn more about what we're doing, and email me directly if you have any questions about my presentation today. Thank you very much.
Hello, my name is Wally Boot. I'm a professor of psychology at Florida State University and an investigator with the National Institute on Aging funded CREATE Center. The main focus of my presentation today will be how technology can support the leisure activities of older adults. As we begin, I'd like to provide a brief overview of the issues I'll be talking about today. When we think about technology to support older adults, we often think about technologies to support everyday activities important for independence, such as technology to support medication management and transportation. There's often much less focus on the potential technology to support leisure activities, including technology to support entertainment and recreation. This is what Wendy Rogers and colleagues have referred to as enhanced activities of daily living, or EADLs. This lack of focus on technology to support fun and leisure is unfortunate because EADLs have the potential to improve well-being, reduce stress, and potentially even maintain cognition. It is important to recognize that quality of life and meaning in life is more than just being able to live independently. In times such as these, technology may play an even bigger role in supporting older adults' leisure activities. Technology can support leisure activities that traditionally might have taken place in person and outside of the home, and technology can provide unique leisure experiences that may enhance well-being under conditions of social isolation. However, for technology solutions to be viable and overcome the digital divide, we have to engage in usability testing, user-centered iterative design. We need to ensure that technology solutions match the needs, preferences, and abilities of older adults. This has been the goal of the CREATE Center. I'll present two studies today briefly that have examined older adults' interactions with technology-based leisure activities and what we have learned from them. More specifically, I'll present studies on aging and gaming, as there's quite a large digital divide when it comes to older adults and video games. We see that from the Pew data on the graph right here that compared younger and older adults' responses to whether or not they sometimes or often played video games. The first study explores the potential of VR technology to support older adults' leisure activities. Virtual reality is a new technology to many younger and older adults. We asked whether younger and older adults would differ in their sense of presence and immersion in VR environments, their experience of workload as they navigated VR environments, and also whether they differed on cyber sickness, which is typically greater for older adults, especially older women. 20 younger and older adults were exposed to 4 different VR environments using the HTC Vive. Sense of presence and immersion were measured with the iGroup Presence questionnaire. Workload was measured with the NASA TLX, and cyber sickness was measured with the SSQ, the Simulator Sickness Questionnaire. Younger and older adults were then asked to navigate a virtual home in an experience called Steam VR Home, explore a virtual mountain peak in an experience called Vesper Peak, engage in virtual meditation by a waterfall using Meditation VR, and they were asked to play a fast-paced action game called Zortex. We can first look at general sense of presence, the sense of being there in the virtual environment. Higher scores indicate greater presence. We also break down the data by experience and gender. Blue bars for younger adults, red for older adults, solid for colors for men, and stripes for women. Red bars are higher than blue bars in general, indicating that older adults experienced a greater sense of presence, so a better experience, a better sense of being there compared to younger adults. The exact same was true for measures of involvement and realism, other measures of presence and immersion. We can also look at various measures of workload. For mental workload, as measured by the NASA TLX, few differences in workload were observed except for the Steam VR Home, the first VR experience they encountered. After that, workload was similar for younger and older adults across experiences. In terms of other aspects of workload, there was no age effect for physical demand, temporal demand, frustration, or effort. So in general, there are few consistent age effects for workload. In terms of cyber sickness, everyone demonstrated low symptoms of cyber sickness, and counter to expectations, older adults report fewer symptoms of cyber sickness compared to younger adults. So in general, older adults report equal or even better experiences with VR environments compared to younger adults, perhaps due to the greater novelty of the simulated environment. There are a few differences in perceived workload. VR was generally considered easy to navigate through, though it depended on the experience. and similar sickness was not a problem. However, it's important to recognize that there were only 4 experiences that were relatively brief, between 3 to 5 minutes. So in terms of applications, there's potential for VR to support leisure activities for older adults, which may be especially beneficial for older adults with mobility issues, and may be especially beneficial and relevant in the era of COVID-19. And of course, there are additional implications beyond leisure in terms of VR to support training, rehabilitation, and functional assessment. So I'd like to briefly talk about another video game data set. The main focus of the PRISM randomized controlled trial was social isolation, and 150 older adults in the study had a computer installed in their home for a year to support social connections and resource access. However, the system also had games, and this provided a unique opportunity to study naturalistic gaming behaviors of older adults. Older adults were not explicitly told to play the games, they were just a feature of the system. And they had the system in their home for an entire year, and we could monitor their use of the system. The PRISM system involved an iterative user-centered design process that involved heuristic analyses and cognitive walkthroughs, focus groups, pilot testing again, and an efficacy trial. So this was the system itself, and 150 older adult participants had the system placed in their homes. Before training, these participants had minimal technology experience. And here are the various word games, puzzle games, and card games that they had access to. Our analysis question here is, if given an easy-to-use system, training, and access to games, can we bridge the digital divide? Will older adults game, and if so, will they continue to do so for the entire year? We can quantify use of the games on the system by the number of days per week they access the game feature. For each of the 52 weeks they were in the study, they could receive a score of 0 to 7. 7 would be that they played the games every day that week. On average, over the year, participants accessed the games feature about 2 days out of every week, with the solitaire game being far most popular. However, this hides some substantial individual differences. Here instead, I plot the number of days each game was accessed over the year, so a maximum of 365. The dots represent very frequent players of other games. For example, one participant played Mahjong almost every day. One participant played poker over 200 days. Many participants became habitual gamers and preferred games differed between participants. So it was not just solitaire. So the PRISM system was useful to and usable by older adults because it was developed with an iterative user-centered design process. You can consult the main outcome paper. Older adults living alone were helped by the system. There were positive effects on loneliness, social support, and attitudes toward technology, but most relevant to the current discussion, although not instructed to, participants used the system relatively frequently to engage in leisure. Many participants in our study actually became active gamers. So some general conclusions. There's massive potential of technology. Technology has massive potential to improve the health, well-being, and independence of older adults. Technology that is not designed with older adults in mind has the potential to lock out older adults from these benefits, further isolating individuals at risk. And although there is a lot of evidence and research on ADLs and IDLs and how technology can support these activities, what we believe with the CREATE Center is there's potential for technology to support EADLs as well, including crucial experiences of leisure and socialization, and these should not be ignored. So we gratefully acknowledge the support from the National Institute on Aging for the research and funding CREATE over the last 20 years. Thank you.